Today, we're digging into a wild idea. What if the secret to keeping our digital world from falling apart wasn't dreamt up in some high-tech lab, but was actually figured out thousands of years ago by an ancient, part-time parliament? It's a fantastic story. Let's get into it.
All right, let's start with a really fundamental problem in computer science. How on earth do you get a bunch of different computers scattered all over the place to agree on a single version of the truth? I mean, really think about it. Servers can crash, messages get lost, they can't even fully trust each other. So how do they do it?
And believe me, this isn't just some dusty academic question. It happens millions of times a day. You've got two people hitting buy on the very last ticket to a concert at the exact same millisecond. Who gets it? The system has to make a call, and it has to be the right call. Without a totally solid way to agree, everything from online shopping to our banking systems would just grind to a halt.
For computers, this is an absolute nightmare. Just imagine you're trying to have a meeting where people just randomly disappear. Your text messages might show up tomorrow or never, or maybe you'll get the same one 5 times. There's no one in charge to coordinate everything. Well, that's pretty much the chaotic reality that these systems live in every single day.
So you'd think the solution to this super modern, high-tech problem would come from a top engineering university, right? Well, you'd be wrong. The answer was brilliantly laid out, of all places, in a research paper disguised as an archaeological report about a lost civilization on the Greek island of Paxos.
And that's a direct quote from the paper's opening line. Peripatetic propensity. I mean, you gotta love it. It's just a wonderfully complicated way of saying that the politicians were, well, they were flaky. They'd show up for a bit, then just wander off. And that right there is the perfect metaphor for our unreliable computer servers that are always crashing and rebooting.
You see, their problem was a perfect mirror of our own. How do you pass laws and keep a consistent record when the lawmakers are constantly coming and going and the messages they send are totally unreliable? They had to be absolutely sure that, say, Decree number 37 meant the same thing for everyone, no matter which group of legislators happened to be in the chamber when it was passed.
Okay, so before they could even think about creating an entire book of laws, the Paxons had to figure out something a little more basic: how to agree on just one single law without causing a total mess.
Because here was the ultimate nightmare scenario. One group of politicians comes in, passes Decree 37 saying no painting on temple walls, and then they all leave for lunch. Then another group comes in, totally clueless about what just happened, and passes their own Decree 37 saying artistic expression is guaranteed. The entire legal system would be useless. That could not happen.
So to avoid that chaos, they came up with this really clever 4-step process. First, in the prepare step, someone steps up to be president and basically asks a majority of the others, hey, will you listen to me? Then, and this is the most important part, comes the promise. Those who agree promise they won't listen to any older proposals. Only after getting that promise does the president actually propose the law in the accept phase. And finally, if a majority accepts it, the law is decided. It's official.
You see, that promise phase is the secret sauce. It's the whole magic trick. By getting a majority to commit to ignoring older stuff, the protocol creates this powerful lock. It means some old delayed message from a previous attempt can't just show up late to the party and ruin a decision that's already being made. It keeps the whole process secure.
Okay, so they've got this rock-solid method for passing one law. That's great. But how do you go from that to building an entire consistent history of laws? Let's see how they scaled this thing up.
And the solution is just so elegant. It's brilliant. They didn't invent some new, complicated system. They just took the protocol that worked perfectly for one law and did it again, and again, and again. They ran one round for Decree number 1, then a whole new round for Decree number 2, and so on, for every single law they needed to pass.
Now, they were really careful about it. One president would handle everything to keep it organized. And before proposing a new law, they had to check in with a majority to find out about all the laws that came before. And here's my favorite part. If they found a gap, like, say, Decree 125 was missing, they had this charming fix. They'd just fill the gap with a harmless placeholder law, like declaring it a National Olive Day, just to keep the numbers in the law book perfectly sequential.
So we've spent some time on this ancient island. But what does all this ancient political drama have to do with the servers running your bank account or your favorite social media app?
Well, the translation is stunningly direct. A Paxon legislator, that's just a computer server. Their law book, that's a database. A decree being passed is just a transaction being processed. And all those ancient problems, legislators wandering off, messengers getting lost, we just call them server crashes and dropped network packets.
They are the exact same problems that engineers deal with every single day.
You see, what those ancient Paxons stumbled upon is a perfect real-world example of what we now call the replicated state-machine approach. It's a cornerstone of reliable computing, and the logic is just unbreakable. If you have a bunch of servers and you make sure they all start in the exact same state, and then you feed them the exact same commands in the exact same order, they have to end up in the same final state. They stay perfectly in sync, no matter what.
And that's the big reveal. The part-time Parliament protocol, known today simply as Paxos, is the algorithm that makes that guarantee. It's the invisible engine working behind the scenes to ensure consistency in our databases, cloud services, and all kinds of critical infrastructure. So the next time you use a service that just works flawlessly, you can thank those flaky part-time parliamentarians who figured it all out first.
But the story has one final cautionary twist. For all its brilliance, the Paxson system eventually failed, and the cause wasn't some complex political breakdown. It was a simple clerical error. A scribe made a typo in a single decree that accidentally locked the entire system, making it impossible to pass any new laws, ever. Their government just stopped. It's a chilling reminder that even the most mathematically perfect systems can be brought down by the simplest human mistake, and it leaves us with a really important question. What are the simple scribe's errors hiding in our own complex digital world, just waiting to bring things to a halt?